Hi guys, this is lesson 91, and we're going to go over linear inequalities. Okay, so for the first one over here, we are looking at two different equations. This one over here, A, y is greater than, and for equation B, y is less than. The equation is the same. They drew the line for us already. It tells us what the equation is, and then they gave us three different points. It is above the line for this example. So when it tells you y is greater than the equation, they're always referring to above the line. When they're saying y is less than, they're referring to below the line. So what they're trying to do is to show you that any of these points can be an answer to either this equation or this equation. Because we already know that when it tells us y is greater than, and all of these points are above the line, this is the equation they're referring to. Now, to show you that it works, we're going to go to the next page. They took those 3 points and put them in the equation where y was greater than. And y is always greater than the number that we get when we plug in x. So it is true for all of them. When y is less than, it is not going to work. So they didn't even solve it because we already know that when y is greater than, it's all of those points above the line. Okay, so then to the next one. Greater than or equal to, or less than or equal to. So looking at this example right here, this equation y is less or equal to 1/3 x plus 2. So again, when y is less than, it's going to be everything below the line. Okay, and now this line over here is solid because y is equal to or less than. The equal sign makes it a solid line. Versus this equation right here, y is less than, it is not equal to. So your line is going to be dotted. The answers do not include any of the points on the line. Here, any point on this line will satisfy this equation. Any point on this line will not satisfy the equation. That's why it's dotted. It is not included in the point that satisfy this equation. So if we were to pick a point, for example, right here, it would not satisfy this equation. But any point below, anything in the gray, will in fact satisfy this equation. Okay, then we're going to move to system of linear equations. Now, they're going to give you two different equations, and then you're going to shade in which part of that graph satisfies the equation. And so I'm actually going to skip forward over here and go to example 91.2. Okay, so they give you two equations. All right, so this is where graphing equations comes in handy. You can use your calculator to graph this to verify that you are correct. It is okay to do that. So first we're going to graph the two lines. Okay, one of them is y is greater than, so it is a dotted line. And one of them is less than or equal to, it is a solid line. Okay, and then we have to shade in all of the points that satisfy the two equations. So for the first one, y is greater than, so we shade above the line. Okay, that's the dotted line, so we shade above the line. We're going up above the line. For the second one, y is less than or equal to, so because it says y is less than, it's below the line that we shade. So we shade below the line. So it would just be this portion right here that satisfies both of the equations. Nothing on this line will satisfy the equation. Everything on this line will satisfy the equation, and any point in between in this shaded area will also satisfy the equation. I hope that all made sense. So now we're going to go ahead and go to practice. Go ahead and do both of them, A and B. You can stop the video here and we'll go over it in just a second. Okay, so here's where we're at. Practice set 91. They give you two different equations. Both of them are greater, or both of them are equal to, so greater than or equal to, and this y is less than or equal to. So both of the lines, and again, if you want to graph it in your calculator to make sure that you're doing this correctly, you can. If you can just graph it on your paper, that's also great. So for the first equation, y is greater than, so you're going to shade above the line. For this one, y is less than, you're going to shade below the line. What do they have in common? This area right here. Both lines are solid because equals equals. Now for B, this line right here, y is greater than, so it's going to be a dotted line. And you're going to shade above the line because y is greater. When it's greater, you shade above the line. Now y is less than or equal to x plus 3. The line is going to be solid line. And you're going to shade below the line because y is less than. So you're shading below. Again, everything in here in that gray area will satisfy both of these equations. Nothing on the dotted line will. Everything on the solid line will. And that is all for this one.